In the last video, we talked graphing inequalities. So in this video, let's talk about systems of inequalities. So we talked about systems of equations, where you have two lines, you graph them, and you figure out where they intersect. Well, with inequalities, we're going to find, remember when you would graph an inequality, you'd have some line, either dashed or solid, and then you would shade. Well, now, graphing systems of inequalities and solving them, we're going to graph two inequalities, and then we're going to figure out where their shaded areas overlap. And that is going to be the solution to our system of inequalities. So let's say we have the inequalities. Y is less than 2/3 x plus 6, and y is greater than or equal to 7. So what I'm going to do is I'm going to go ahead and graph both of these. So I'm going to graph the first one in green. So y is less than 2/3 x plus 6. And remember, it's the same as graphing a line, except this inequality symbol tells you, will I have a solid line or a dashed line? In this case, it's less than, I will have a dashed line because there's no equal to. So, less than 2/3 x plus 6. I'm going to go up 6. So 1, 2, 3, 4, 5, 6. There's my y-intercept. 2/3 is my slope, so I'm going to go up 2, 1, 2, over 3. 1, 2, 3. And I'm also going to go down 2, 1, 2, and to the left 3. Because negative 2 over negative 3 is the same thing as a positive 2 over 3. Okay, so now I have 3 points. Again, I really only need 2 to graph a line, but I like to do 3 just to be as accurate as possible. Okay. All right, so now I've got my line. All right, so we've got our line here. However, that is a less than sign, so this needs to be a dashed line. So I'm going to just take my eraser here and break up the line such that it is dashed. All right, so now we have y is less than 2/3 x plus 6. Okie doke. So now what we're going to do is we're going to graph y is greater than or equal to 7. Okay, so in this case I don't have an x. So if you remember, if we don't have an x, we don't care what x is. We only care what y is. And in this case, y has to be greater than or equal to 7. So y has to be 7 at all times. So let's go up 7. So 1, 2, 3, 4, 5, 6, 7. So there's a point on the line. Let's see, I could also have this point. Y is 7 at that point. Y is 7 also at this point. All right, so I've got y is greater than or equal to 7. This is a greater than or equal to. This equal to symbol tells me I'm going to have a solid line. So let's go ahead and graph this. Have a solid line here. There we go. Okie dokie. So now we have our two inequalities graphed. So when we graphed a singular inequality, we would pick a test point on each side of the line. We would plug that point back into our inequality to figure out if that point made our inequality true, and then we would shade that area. Well, this time, we're going to look at all the different regions that we have here. So we have, we'll say region 1, 2, 3, and 4. So we have all these different regions that we could possibly shade. And we're going to pick a test point in each one of these regions. So let's start in region 3. My favorite test point, 0, 0. And that is an option in region 3, which I really appreciate. 0, 0 is the easiest one to plug in. All right, let's go to region 2. So I'm going to pick this test point in region 2. So let's figure out what that is. That's 1, 2, 3, 4. And so that's negative 4, 1, 2, 3, 4, 5. So we have negative 4, comma 5. All right, now let's go to region 1 here. I'm going to do this test point. So that's negative 2, comma 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2, 9. And we'll go to region 4. We'll do this one. And we have 1, 2, 3, 4, 5, 7. 7, comma, 1, 2, 3, 4, 5, 6, 7, 8. 7, comma, 8. Alrighty, so now let's look at this. Before we start, plugging in these points, let's think about this logically. We have y is greater than or equal to 7. So whatever point we pick, in order to make both of these inequalities true, or at least to make this inequality true, y has to be greater than 7. So that automatically eliminates what two regions? It automatically eliminates regions 2 and 3 because we don't get above y equals 7 in either of those regions. So now we only have 2 regions to test. So let's try region 1. So -2, 9. All right, so let's plug it into our first one. 9 is less than 2/3 times -2 plus 6. Alrighty, so then we get 9 is less than -4/3 plus 6. I'll do that in my calculator, -4/3 plus 6. And I get 9 is less than 4.7. All right, approximately. I rounded that off. It's 4.6 repeating, but we'll round off to 4.7. That is not true. So we'll just say nope, not true. Okay, so region 1 isn't going to work, so let's make sure region 4 will at least work. And remember, it has to work for both of them. So in a different color, let's do region 4. So we're going to have 8 is less than 2/3 times 7 plus 6. We have 8 is less than 14/3 plus 6. And then we have 8 is less than, again, we'll go to calculator here. And we get, well, if I would plug it in correctly, we get 10.7. So 8 is less than 10.7. That is correct. Now let's check the other one. We have 8 is greater than or equal to 7. That is also correct. So the solution to this system of inequalities is going to be, we're going to shade in everything in this region. That is the solution to the system of inequalities, because none of these other ones work, but every single coordinate in region 4 here will satisfy both of these inequalities, therefore making that the solution.